Alright, hello grade 9s. I am very sure that you missed me by now. Anyway, I am going to teach you about gradients. So I got a couple, well actually, only one of you bothered to tell me what you were struggling with. So I'm going to assume the rest of you are super awesome with everything that you've been learning. But anyway, we are going to talk about gradients. So this should cover how to calculate the gradient from a line, but also it's going to talk about how do we interpret gradients. So we're going to leave calculating gradients from points until I get back. I'm hoping to be back next week. So cross your fingers for me, please. And maybe your toes if you've got some spare time. But back to this. So gradients in a real life context. So we are going to make sure that we can calculate the gradient of a line. We're going to talk about how do I contextualize the gradient of a line. So how can I interpret it to get some information, and extrapolate using the continuation of gradient of a linear graph. So that's just extending it and finding a value. Okay, so conversions. I want you to pause the video, do the starter in your books quickly, please. It should not take you very long. All of you should be able to do that. It should not be difficult. Okay, so remember there's 60 minutes in an hour. Okay, and that's fine. Anyway, so then you're gonna, once you've paused it, you're going to check your answers. Make sure you did those correctly. This is going to help us when we're talking about gradients in terms of the context of time. Okay, so if I'm looking at these points, so if I'm finding coordinates, remember that I go x, comma, y. Okay, so it's always x first, then y. So I want you to write out the points, the coordinates for me. Whoops, sorry. So you're going to write out the coordinates for me. So pause it, and then once you've paused it and you've written out your coordinates, so k is going to be 1, 4, L is going to be 4, 6, M is going to be 5, 1, N is going to be 6, 3. Okay? So those should be your correct answers. Make sure you give yourself ticks if you've done this correctly. Okay, gradients. So gradient talks about the slope of a line. Okay, we find the gradient by calculating the rise, so the y, over the run, the x. Okay, so if I look at this straight line here, if I want to find the gradient of that line, what I'm going to do is I'm going to choose 2 points that I can find the exact value of those 2 points. Okay, so you want to choose something that is right on a point. Okay, so I don't want to choose something that's like partway here that I have to estimate what my actual values are. You want to choose something that's got an exact x and an exact y. Okay, and then what we do is we measure the distance vertically. So how do I go from this point to this point? Okay, I'm going to measure the up. So I would actually do it this way personally, but that's just me. And then I measure the over. Okay? And you want to kind of be careful with this diagram here, because this kind of implies that we're moving in a negative direction, which isn't the case. Because remember, my x value starts here, right? So I go up +6, and then I go over +4. Okay? Which means that my gradient is going to be 1.5, or 3/2. Doesn't matter. Okay? So we can use decimals just because it makes it a little bit easier. Okay? Now, this worksheet is going to be attached for you, there's going to be a worksheet attached for you that I want you to calculate the gradients. Okay? You don't need to draw out the lines, you just need to calculate me the gradients. So, if we look at this example here, if I start here, I need to find 2 points that are right on that line. Okay, so I'm going to count up, I'm going to go 1, 2, 3, 4. Okay, and that's my rise. My run is going to be 1, 2, 3. Okay, so the slope of this line, the gradient, of this line is going to be 4/3. Okay, and again, I don't love the fact that they've drawn their triangles down below, but the idea is the same. Okay, let's look at this one. So for this one, again, I'm going to choose a line that's right on that point there. So I got this one. Okay, and actually what I would choose is this one here. So I'm going to go up. Okay, so I'm not actually sure where I've left off here, but anyway, so for this one, we've got the gradient that we're going up 4/3. Okay, Now, if we look here, this one is not actually a very good example, so I'm going to skip this one. They're saying that it's 3 over 5 because they're saying that this point is here and this point is here, but the line's not drawn very well, and I can't manipulate it, so we're going to skip that example. So I don't agree with it. Okay, this one. This one, I've got a point here, I've got a point here, okay? So if I go up 1, 2, 3, and I go over 1, 2, 3, okay, my fraction's going to simplify to 3 over 3, so I've got 3 over 3 simplifies to 1, right? If I want to use the same points that they're using, so they're going from here to here, okay, so they're going 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. Again, it's going to simplify, and it's going to give me a gradient of 1. Okay, and again, remember you want to go up and then over so that you're thinking this is moving more positive on the x-axis. Okay, if we look at this one here, again, this one looks different than the other ones because it's going the opposite direction, right? But for this one, if I start here, if this was x equals 1, this would be x equals 2. So actually for this one, I am going down. So I'm going -4. I'm going over 1, which means my fraction is going to be, my gradient is going to be -4 over 1. Okay? Same with this one. This one again is a negative gradient. So this one we're going down 2, and we're going over 1, 2, 3, 4, 5. So I'm going to have -2 over 5. Okay? And then that one again, -4 over 1. Okay? So I want you to take a look at the sheet. Okay? Again, so if it looks like I could ski down it, that means I've got a negative slope. If it looks like stairs and I have to climb up it, that means I've got a positive slope. Okay? Sorry, I'm going to switch back and forth between slope and gradient. Okay? In Canada, we tend to talk about the slope, whereas in Britain, we talk about the gradient. Okay? Again, those are interchangeable terms. It's not going to make a difference. Okay? So, gradient, again, if it looks like I can ski down it, negative gradient, climb up it, positive. All right. So, now I want you to pause the video, take a look at the gradients, okay? Do not just write the answer in your books, please. Okay? Now, if we look at this, this is an example of when I can kind of contextualize gradient because it can tell me something about a graph. So, if I look at this, I want you to think about what sort of journey can it represent? What does it represent when I've got kind of a steep gradient? What does it represent when I'm flat? Okay? Think about, if this is distance, what's happening with the person as I'm here, okay? And what we're thinking about here, if the line is flat, that means my distance isn't changing, but time is passing. So that would be the person not moving, okay? Whereas if the gradient is, moving positive quite steeply, that person might be running, or maybe they're in a car. Okay, so we want to think about what does that gradient kind of measure. And hopefully the idea that you're coming up with in your heads is that it measures speed. Okay, and if we think about, our speed, distance, time triangles, okay, we've got speed equals distance over time. Gradient is going to be the rise over the run, right? So it's going to be distance over time. So it makes sense that the speed would be our gradient. Okay. Now, what about this kind of graph? So if I look at this graph, I want you to think about what's the difference between those two graphs. I want you to think about, what's happening here versus what's happening here. Where is the person going? What might a negative speed represent? And think about, if I'm talking about distance, if I'm talking about location, how would I represent moving back towards where I started? So if I started here, say I started at home, okay, and then I, went somewhere else and then, took a little break and then started moving very quickly back towards home, that might be what this graph represents. Okay? And if I think about the fastest part, what do I need to think about there? I need to think about the gradient. So the steeper the gradient, okay, the faster my speed is. Whereas if I look here, this gradient is fairly steep, okay, but this gradient here is steeper. So we started off moving really, really quickly, then, kind of slowed down our speed, then completely stopped, and then very rapidly, returned back to where we started. So a distance time graph gives information about how far someone or something has traveled over a given time period. I want you to write that down in your books, please. Travel graph is read in a similar way to conversion graphs, but you can also find the average speed from a distance time graph using the formula. So the formula is speed equals distance over time. I know it's a little bit different than how we usually write it. We usually write the S here and the T here, but that's fine. Idea is the same. Okay, so again, you can manipulate that formula however you need to find what you're looking for. Okay, so when I want to solve for values, okay, I need to use coordinates for my graph. Okay, so if I look here, the distance time graph below represents a car journey from Barnsley to Nottingham, a journey of 50 kilometers, and back again. So again, if we look, there's this time where the slope, the gradient is negative, right, and tells us that we're returning back to where we started from. Okay, so if I say points B, C, and D, so what I know about points B, C, and D is that they're all along the way from Barnsley to Nottingham. Okay, and from D to F, I know that I stopped. Okay, I stopped and rested in Nottingham for a bit. Some time passed. We spent from time, let's say about 45 to about 75. So let's say we spent about a half hour in Nottingham, just kind of estimating there. And then we drove back from Nottingham to Barnsley, and it took from time 70, probably around 70 actually, to about 130, I would say. So about an hour. Okay, and then if we work out the average speed for each of the 5 stages of the journey, again, you're going to want to find the gradient. So if I look, I want to start from A and then go to B. Now, it's a lot easier actually if you've got the graphs printed out in front of you. My eyesight is not super great, so we're gonna do our best here. We're gonna do a little guesstimation. So we're going up to 15. Let's see here. We've got 2, 4, 6, 8, 10. Okay, good. So we went up 12, 14, 16. So we're going up 16, and then we're going over 20. So the gradient there is going to be 16 over 20. When I simplify that, I get 8 over 10, 4 over 5. Okay, so I know that I've got 4 over 5. So 4 kilometers per every 5 minutes is our unit here. So 4 kilometers, so 0.8 kilometers in a minute, approximately. Okay, then if we look here, our gradient's going to be a lot steeper. Okay, so again, I'm at, it'd be really helpful if I could just write in my points here. So this one we've got 20, and then our y value we said was 2, 4, 6, so 16. Okay, and then if we look here, we're going to have so 22, 24, let's say 25. And that's 25, 33. And coming back to that idea of calculating our gradient from 2 points, if I have the coordinates, I know that m, so my gradient, equals y2, so my second y coordinate, minus y1, my first y coordinate, so that's just my change in y, over x2 minus x1.